Good morning, guys. So I'm going to talk you through how to carry out an ANOVA test, which is one of the statistical tests that you are going to need to learn for biology. You are going to need this for this surface area to volume ratio right up, but you may also need it for your IA later on, like your proper IA. It's actually a very common one that people end up using, so it's one worth knowing. So what you should be able to remember from grade 10 is that when we do any statistical test, you need to have a null and an alternative hypothesis. And the null hypothesis is essentially that there is no difference or there is no correlation between your data sets. The alternative hypothesis is that there is a difference or there is a correlation between the data sets that you have. And so the objective of a statistical test is to be able to see whether or not you can reject the null hypothesis and accept the alternative hypothesis. And the benchmark for being able to do that is based on the p-value. And again, you should remember what a p-value is from grade 10. So a p-value is basically the probability of the results occurring by chance. And so in biology, we use a threshold of p being less than 0.05 as our threshold. So as long as your p-value is less than 0.05, what this is basically saying is that there is a less than 5% chance that these results occurred randomly or by chance. And so there is effectively a more than 95% chance that the differences that we observe are due to a true difference. And so given our p-value being less than 0.05, we can reject the null hypothesis and accept the alternative hypothesis, which is the objective of this test. And as I said, there are a number of different tests that you are going to need to do. You will have access to this flowchart around when you do your IA, and we are going to be covering a lot of these different tests at various points throughout the course anyway. And so if you're looking at correlation, relationship between variables, there are a number of different tests you can do around here. This is where we are right now. So if we're looking for differences between groups, if there are only two groups, we would be doing a t-test, but because we have more than two groups, we are doing an ANOVA with a post hoc test. Another test that we are going to learn through this course is the chi-squared test, which is when there are differences between frequencies, and so we'll come to that when we get to it. What is really important to note is when you're doing any statistical test, you really shouldn't do them if your sample size is less than 5. You do need a kind of minimum sample size of 5, ideally closer to 10 really, if it allows. So that is something that you do have to bear in mind. If when it comes to, say, your real IA, you don't have a sample size of more than 5, you can still do a stats test, but you do need to be very cautious of the results, and you need to be very, you need to show due consideration as to how reliable that result is, because it's not really appropriate on sample size that's less than 5. So this is, as I say, today we're going to learn about an ANOVA, and so this is a test that compares the means and variances between more than two groups. So as I said a second ago, if we only had two groups, we'd be doing a t-test, but because we've got more than two groups, we are doing a ANOVA. And this, as I said, is a very common stats test that you might use in your IA, because very often people are comparing multiple groups, and so this is the most appropriate test to use. After an ANOVA, you do need to do something called a Tukey post hoc test, and this is because an ANOVA will just tell you generally if there is a difference across all three of your groups, or however many groups that you are comparing. So if you've got 3 groups, 4 groups, 5 groups, 6 groups, whatever it is, the ANOVA will just tell you whether or not there is a difference across all of those groups. What it can't tell you is differences between individual group pairings, so between groups A and B, or B and C, or C and D. So to get that, we need to do a Tukey post hoc test. And so fortunately for bio anyway, we don't need to be able to do the math for any of these. We can use online calculators to get these results. So I'm going to show you how to use the online calculator on Stats Kingdom in order to get your results. So, don't worry about normal distribution. If we go over here, so we will put the link to Stats Kingdom into your classroom, or if we give you access to this PowerPoint, you will also, slides, you will also see the link there as well. So it will take you to this page anyway. So this is the ANOVA calculator with a Tukey post hoc test afterwards. This top box here, you can just leave it as it is. You don't have to touch anything in there. The significance level is 0.05, which is what we want, and then just don't worry about any of these things. And then here is where we're going to enter our data. So let's assume group 1 is for your smallest block, the 0.5 by 0.5 by 0.5 block. Group 2 is the 1 by 1 by 1, and group 3 is the 2 by 2 by 2. So in these boxes here, I've put the percent differences, the percent diffusions for each of the replicates. So you did 5 blocks of each size, and so you should have 5% diffusion values. And so you're going to type each of those in to these boxes here. So for group 1, which is our 0.5 by 0.5 by 0.5, group 2 is the 1 by 1 by 1, and group 3 is the 2 by 2 by 2. And then you're just going to press calculate. And down here, you're going to get a box where essentially the only thing we really are worried about is the p-value. So the p-value over here is 1.041 to 10 to the minus 12, and so you should be able to see that that is much lower than 0.05. So we have a significant difference across our group, which is great. So our ANOVA has just shown us that there is a significant difference across our 3 groups. However, as I said a minute ago, we still don't actually know what about between group 1 and group 2, or group 2 and group 3, or group 1 and group 3. We don't know those pairwise comparisons yet. So if you keep scrolling down, there's all this other information here, which you don't need to worry too much about. You can have a look at it if you want to, but you don't have to worry too much about that. This is the second box that we're going to look at. So this is the Tukey HSD or Tukey Kramer box. Here, where it says pair, and then you've got times 1 and times 2, times 1 and times 3, times 2 and times 3. These are the groups. So this is basically comparing group 1 and group 2, group 1 and group 3, and then group 2 and group 3. So it's doing the pairwise comparisons for each. And over here, it tells you the p-value for each of those pairwise comparisons. So between group 1 and group 2, the p-value was 1.375 times 10 to the minus 10. So again, highly significant. So the difference between the percent diffusion in the 0.5 block versus the 1 centimeter block is highly significant. Similarly, between group 1 and group 3, where again a p-value that's far below 0.05, and the same with group 2 and group 3. So the p-value is again much lower than 0.05. So all of these pairwise comparisons are also significant as well. So for your IA, for the surface area to volume ratio, this is what we expect you to do for this one. So we want you to use the ANOVA to see if there is a statistically significant difference between your groups, and then look at the Tukey post hoc test as well to look at the pairwise comparisons as well. Bear in mind that the data that I inputted above was completely made up off the top of my head, and so I have got highly significant results here. You may not get that, and that's absolutely fine. You just need to discuss this critically and objectively in your conclusion. So what do the results of your stats test show you? So the statistical test is kind of like the last layer in terms of your analysis. So you've got your raw data, you've processed it, you've then got a graph, you can look at the trends that you observe in the graph. The stats test is then there to support the trends that you observe. So if you can see that there seems to be a huge difference in percent diffusion between the smallest block and the largest block, the stats test will help support that. So we have to be careful not to say that it proves anything, because it doesn't, but if you get statistical significance, it supports the hypothesis that there is a difference between those two groups, or there is a relationship between this and this, or whatever your research question is. So it's the last kind of level as far as our analysis goes, and supporting what our data is showing us, usually graphically. So I hope that makes sense, and let either me or Miss Emmerich know if you have any questions and need to go over that.